Hello students, today we're going to look at distributed property with polynomials. First, a quick review of distributed property. We multiply here, we get 3x minus 24. When we take the 3 and multiply times both terms in the parentheses. So today we're looking at multiplying monomials times any polynomial. We will use algebra tiles in class, but that's something we're not going to do here on the video. We'll look at that when you are in person in class. So for example, on this one, we just distribute the x. So x times x, we get x squared plus 2x. And that's all we're going to do on these. There's nothing else solving. We're just looking at one step where we simplify. Always look to see if we can combine, but these are not like terms because the exponents have to be exactly the same. This one, we're going to get y squared minus 3y. So all we're doing is taking this term and distributing it to both. Or remember 3. We distribute again, we get 3a squared minus 3a times negative 1, we get minus 3a. All right, on number 4. So feel free to pause if I'm going too fast at any point. Distribute here, we get 4b. And then on the second one, because we had 2 times 2 was the 4b. The second one we have a 1 here, so 2 times 1 we get plus 2, but b squared on that one. So feel free to pause if you need to catch up. But there is the distributed property with a monomial times a two-term polynomial, a binomial. All right, going down to here, we're going to distribute again. We can multiply times any terms. For this one, we get 2x times x squared. That's going to be 2x to the third because we add the exponents plus 10x. So that's what we get on number 5. All right, and we just keep going with a lot of distributed property here. So I'll keep rolling with this, and you guys can feel free to pause at any spot if you need. So in this one, we get 7 times 4, we get 28. We got a 1 and a 3 for the exponent, so that's y to the 4th, minus 21y. That's it. They're not like terms, so we can't combine them. So we go on to 7. We get 4a to the 3rd, plus we're going to have 56a squared. And then last, we get minus 8a. All right, so we got a one term times a trinomial. We have no like terms, so that's the best we can do in simplifying it. Then number 8, we go on, we have got a bunch of terms here. We got 4 of them. So we're going to have 16, 5 and 2 for the exponents. We get m to the 7th. We get minus 10. We get 2 and 3 this time, so that's m to the 5th. We've got plus 3, 2 and 1 is m to the 3rd, and then minus 9m squared. So there we go. So there's nothing to combine there. These are all m's, but they're not the same exponents, so they are not like terms. Feel free to pause that, like I said, to check and catch up. So we're doing a lot of distributed property on this one. All right, at times there can be more. Not a very good R there. Okay, at times there can be more than one variable involved. So we're going to look at some examples with more than one variable here. So on number 9, we still do distributed property, but we're going to get 3, 1 and 1 on the exponents for x, so that's x squared, but there's no other y's. So we just follow our exponent rules, and we try to simplify this. So this time we got minus 5. We do typically keep them in alphabetical order. So there's no x's. Y times y, we get y squared. Those are not like terms because it's x squared y, x, y squared. They're two different things. All right, number 10, distributed property. We get 30 n to the 3rd, and we get minus 170. Now this time we got n and n, so n squared. And then there's no other y, so it stays y to the 3rd. That's all we get for number 10. So pause that one if you need to catch up. All right, on number 11, we're adding even more stuff to it now. Now we got negative 13 times 2, so negative 26. C's, we got 2 and 4, so c to the 6th. 3 and 1, so that's d to the 4th. Negative negative is plus 65, c to the 3rd, and d to the 3rd. So that is everything on that one, right? So again, we're just doing distributed property and then being careful with your laws of exponents. All right, number 12, we get 27 x. Now, we've got a negative exponent, so 3 plus a negative 2, we actually get x to the first. And then m, we got 1 and 1, so m squared. And then we go here, we're going to have plus 9. We got x, we got 3 and 1, so x to the fourth. And the m's, we got 1 plus a negative 1 is 0, so m to the 0 actually just goes away, because if we had m to the 0, that equals 1. We don't need to write times 1 here at the end, so that's why that one actually just goes away and cancels out. All right, the last two here, 5 times 3, we get 15. We've got a to the third, because we've got a 1 right there, b squared for that one. 5 times 5 here, we get plus 25. We got 1 and 1 is a squared, b to the third. And then last, we get minus 40. We got a, there's no other a's, but we have b squared, and b squared is b to the fourth. Okay, so that's what we end up getting for that one. Double checking there, 15. We got a to the third, b squared. We got plus 25, a squared. Just 2 and 1 is b to the third. 5 times negative 8, we get minus 40. There's just the a, and then 2 and 2 is b to the fourth. All right, last one here. We get 20 a squared b squared c, because there's an ab and an ab, but no extra c, so that's why it's c to the first. Plus we're going to have 30 a squared. There's no b's, so it stays b to the first, c squared. And then last here, now notice we do have ab's that are the same. So what happens, we get minus 40, we got a squared, we got b squared, and then there's a c. So actually, if you look, you always want to double check, do I have any like terms at the end? This time we do. The a squared, b squared, c is both of those. So I'm just going to write the 30 a squared, b c squared out front. And then 20 minus 40, I actually get negative 20. That's where I keep the exponents the same. So a squared, b squared, c. And this ends up being my answer, because this is a different term with b to the first versus this is a squared, b squared. So those last ones we can't combine. If you have questions, certainly reach out on Canvas, and hopefully that helps you get through these notes on multiplying a monomial times any polynomial. Thank you.